In today's session, we are going to discuss with you calculations of 24-hour urine proteinuria, which is used to rule out kidney conditions like glomerulonephritis, people with nephrotic syndrome, people with uncontrolled diabetes, and people with hypertension, so that we can monitor them to see if they are responding. So that's why we measure 24-hour urine proteinuria. And the first thing to note is, how do we correct a 24-hour urine sample? So as we begin, we urge you to subscribe. Go to the subscription button and make sure you subscribe, like the video, and share to many others so they can continue to learn at Medical Sciences by Naftali Muhumuza. So 24-hour urine proteinuria, the first thing is, how do we collect this urine? Assume a patient has come at 9 a.m. in the morning. You provide this patient with a clean, dry container. And this clean, dry container should be 2 to 5 liter capacity. Then you label with details like lab number, the name of the patient, and the start time. And here our start time is 9 a.m. So when 9 a.m. reaches, you instruct the patient to empty the bladder. Here you instruct the patient to empty the bladder exactly at 9, and then you tell this patient to start putting urine, to put every urine from 9 a.m. after emptying, that every time they feel urinating, they should put urine in the container. And every time they add the urine, they should mix with the preservative like thymo or boric acid or any other preservative which you provide. So there must be a preservative. So every time this patient from 9 a.m. after emptying the bladder, every time they feel urinating, they urinate in the container, mix with the preservative, then they recap the container. Then they keep putting urine until 9 a.m. next morning or next day. So on the 9 a.m. of next day, you instruct this patient to put all the urine to urinate, or to put all the urine in the bladder or urine. Even if though they are not feeling to urinate, they should go and force, so that the last portion of urine is also added, and this urine, they should indicate the time they have finished. After indicating the time, which is still 9 a.m., then they should bring it immediately to the lab without delay. So this is the process how you can correct a 24-hour urine. And after correcting it, we are going to see different methods we are going to use to calculate, whereby the formula is that 24-hour urine protein is equal to protein concentration in grams per liter times total protein, total volume of 24-hour urine in liter. So when they bring this 24-hour urine, you have to measure it in liters and record. So this is the formula we are going to use to calculate 24-hour urine proteinuria, whereby in case you're given protein concentrations in gram per liter, you are in milligrams per deciliter, you have to convert. And in case you are given total volume in mils, you have to convert it to liters. So the first example we are going to use, here we are given the standard, whereby the protein standard is 300 milligrams per deciliter. So since it is in milligrams and we want the answer in grams per liter, we shall convert it to grams per liter. Then even the volume, we are seeing it is in mils, so we are going to be forced to convert it into liters so that we can get our 24-hour urine protein. So we're going to start by, since we are given with 300 milligrams per 1 deciliter, we are going to start by converting, here we are going to start by converting, whereby we are going to convert 300 milligrams to grams, whereby 1,000 milligrams is equivalent to 1 gram. What about 3,000 milligrams? We cross multiply and we get 3,000 milligrams times 1 gram divided by 1,000 milligram. Milligram goes with milligram, 2 zeros goes with these 2 zeros, and we remain with 0.3 grams. So 300 milligrams is equivalent to 0.3 grams. And what about 1 deciliter? We know that, so the next thing is to convert 1 deciliter to liter. And we know that 10 deciliter is equivalent to 1 liter. What about 1 deciliter? Is equivalent to 1 deciliter times 1 liter divided by 10 deciliter. Deciliter goes with the deciliter. We remain with 1 deciliter out of 1 liter out of 10, which is equivalent to 0.1 liter. So 1 deciliter is the same as 0.1 liter. So we come and substitute in this, that from 300 milligrams divided by 1 deciliter, we have seen 300 milligrams is the same as 0.3 grams. Then we divide by 1 deciliter, which is the same as 0.1 liter. And the end result, we are going to get 3 grams per liter. So 300 milligrams per deciliter is the same as 300 grams per liter. So after converting 300 milligrams per deciliter to grams per liter, now we are also required to convert 1,800 mils to liters, because the volume should be in liters. So convert 1,800 mils to liters, and we know that 1,000 mils is equivalent to 1 liter. What about 100 and 800 mils? You cross multiply times 1 liter, and you divide by 1,000 mils. Mils goes with mils, 2 zeros goes with this. We remain with 18 over 10, which is 1.8 liter. So after converting all the units to the required according to the equation, according to the formula, we are going to say from 24-hour urine protein equaling to what? To protein concentration in grams per liter times the total volume of 24-hour urine in liter. We already have this, we have this. We substitute, which is 3 grams per liter times 1.8 liter, and this liter is going to go with this liter. We remain with 5.4 grams per 24-hour urine protein. So this one becomes our 24-hour urine proteinuria. So the final answer is 5.4 grams, because if you get 3 times 1.8, you get 5.4. So this is how we calculate this. The major thing is to identify the units and you calculate accordingly. You see if we need to convert. So we have seen that 3 grams times 1.8, we are getting our 5.4 grams per deciliter. So here, number 1, the final answer. Number 1, the final answer, we have got 3 grams per liter times 1.8 liter. We have seen a liter goes with the liter. We get 5.4 grams per 24-hour urine protein. This is our final answer, because they wanted 24-hour urine proteinuria. Then the second exercise or example, we are given a 24-hour urine proteinuria of 2 grams per 24-hour urine, and the protein concentration is in milligrams. So I'm seeing here you have grams, here you have milligrams, and the units should be the same. The units should be the same. So the first thing I'm going to do is to convert 200 milligrams per deciliter to grams per liter. So here we are going to convert 200 milligrams over 1 deciliter to grams over 1 liter. And we know that 1,000 milligrams is equivalent to 1 liter, to 1 gram. What about 200 milligrams? Is equivalent to 200 milligrams times 1 gram divided by 100 milligrams, 1,000 milligrams, and 2 zeros goes with these 2 zeros, remain with 1, which is 0.2 grams. Milligrams go with milligram. After getting 0.2 grams, we are now going to convert 1 deciliter to liter. And 10 deciliters, we know that it is equivalent to 1 liter. What about 1 deciliter? Cross multiply to get 0.1 liter. So 1 deciliter is the same as 0.1 liter. So after converting this, we are going to see that we're going to substitute it here. 200 milligrams over 1 deciliter. 200 milligrams is the same as 0.2 grams over 0.1 liter, and we get 2 grams per liter. We get 2 grams per liter. So 200 milligrams per deciliter is the same as 2 grams per liter. After doing that, we are going to substitute in our formula, which says 24-hour urine protein is equal to protein concentration in gram per liter times total volume in liter. And we are given 24-hour urine proteinuria as 2 grams, which is equal to the protein concentration, which we have got here, 2 grams per liter, then times the volume which we want. So from here we make the volume the subject of the formula by dividing both sides by 2 grams per liter, 2 grams. This goes with this. We remain with the volume equaling to 2 grams divided by 2 grams over liter. We get 2 grams out of 1 times, you take the reciprocal, get liter over 2 grams. 2 grams go with 2 grams. We remain with 1 times 1, which is equal to 1 liter. So the volume of 24-hour urine is 1 liter. That is the final answer. So therefore, I'm going to say that the total volume of 24-hour urine is 1 liter. So this is how we can get it. So always identify what is given and what is required and which units do we need to convert. For example, here, the trick was here that it is milligrams and here we have grams. So we are forced to convert. That is the trick. So the last example we can use in this video, you're given with 24-hour urine output of 1.8 liter. And the 24-hour urine proteinuria is 3.6 grams. But they want the answer, look here, they want the answer in milligrams per deciliter. But the answer of proteinuria is grams. So meaning we are going to be forced to convert grams to milligrams, and we are going to be forced to convert 1.8 liter to deciliter. So the first thing is to convert 1.8 liter to deciliter because they want the answer. This one is dictating it. And 1 liter is equivalent to 10 deciliter. What about 1.8 liter? Get 1.8 liter times 10 deciliter over 1 liter. Liter goes with the liter. Remain with 18 deciliter. After remaining with 18 deciliter, another thing we need to convert is 3.6 grams to milligrams. So another thing, convert 3.6 grams to milligrams because we are going according to the question, and 1 gram is equivalent to 1,000 milligrams. What about 3.6 grams is equivalent to 3.6 times 1,000 divided by 1, which we get 3,600 milligrams. So we have also already converted this also. So after getting these two, we have converted a liter to deciliter and grams to milligrams, and they want the answer in milligrams per deciliter. So now we are going to use the formula. We are going to use our formula which says that 24-hour urine protein is equal to protein concentration. Here they want it in milligrams per deciliter, is equal to protein concentration times total volume. The 24-hour urine proteinuria is 3,600 milligrams. Equaling to protein concentration, which we want, times volume, and volume is 18 deciliter. So we make protein concentration the subject of the formula by dividing both sides by 18 deciliter. 18 deciliter. This one goes with this, and we remain with protein concentration equaling to by 18.1 by 18.2 equaling to 200 milligrams over 1 deciliter, which is the same as 200 milligrams per deciliter. So this is the protein concentrations which they wanted in milligrams per deciliter. So you end up getting 200 milligrams per deciliter. So here, the trick of the question was, the examiner was commanding you to calculate in milligrams per deciliter. So that's why we were forced to convert this one to milligrams and convert to 1.8 liter, also to deciliter. So this is what we can discuss in this session. And to those who don't want to pass through all this, still there is a shortcut of the formula which we can employ, which is always given like this, that 24-hour urine proteinuria, 24-hour urine proteinuria, protein is equal to protein concentration, if it is in milligrams per deciliter, times total volume of 24-hour urine in mils. You divide this by 100, then over 1,000. This formula is also used directly to get the answer without using first principles. So if this is in milligrams and this is in mils and we want the answer in grams per 24-hour, you use this formula. Protein concentration, if it is in milligrams, you get the total volume in mils, you divide by 100, then everything is over 1,000. The way we had it here, that if I want it, I'm given, I can easily use these figures in the number 1, whereby we had 1,800, and we also had 300 milligrams per deciliter. So if I am to use this method, which is a shortcut but it does not give you all the answer, the first principles is the best. You can come and get your 300 milligrams per deciliter times total volume, and the total volume was 18 mils. You divide this by 100, then everything over 1,000. So 18 times 3, or I can leave it like that, it becomes 300 times 1800, 18,800 out of 100, then divide by 1,000. This is the same, over 1. I take the reciprocal, I get 300 times 1,800 out of 100 times 1 out of 1,000. This one goes with this, and these 2 will go with this 2. We're going to remain with 3 times 18, which is 54 over 10, and the answer becomes 5.4, which was the same for this when we did it from first. But for better understanding, it is better to do it from first principles. This one will be in grams per 24 hour. So this is how you can do it if you want to avoid the first principles, but this is not the best. So we saw the first formula, and this is another formula for converting them directly. So thank you so much for learning with us. Hope you have gained something from this video. Continue to subscribe, like, and share to many others. Thank you so much.